Hello everyone, my name is Fatih Bahamarolu and my partner Nikita Liz will be trying to present our simulation project. So Lamar University does offer many places to eat in campus, but in the late evening it doesn't have variety of options. So students who live at the dorms have really limited options. And one of their options is a store called Outtakes, which is located at the Monroe Hall. It's not only a food store, it also serves as a convenience store, which also serves Papa John's pizza. Since this place is the only option that students have after some certain time period, store gets really high demand during the peak hours. And sometimes you can see that huge line even the outside of the store. This can be really frustrating for the students who live at the dorms actually, because the students sometimes need small grocery needs or they're feeling really hungry. They want to grab a real quick snacks or food or grocery needs, but there's always a huge line, so they can't really grab it and leave. And that's really frustrating for the students who wants to wake up early and go to their classes in the next day. So my partner and I decided to take a deep look at this store and see what is the problem and how can we improve it. Here you can see our flow chart. First, customer arrives to the store, then they have six options what to buy. They can buy pizza, groceries, and drink, or they can only buy pizza and groceries. They can buy groceries, pizza, drink, and individual other stuff. Actually, the store has more than these options. Well, we only list the ones that are the most popular ones. Then they go to the checkout process, then they leave. And here's our project outline. We define our entity as customers since we have only one type of customers that those are the only entities we have. We have resources, two pizza servers, drink fountains, and cashier. We have four processes, getting a pizza, choosing a grocery, getting a drink, and checkout. We also use sequence module in our model. Since our model is a lot of decision making for the customers, we didn't want to use so many decide modules. We wanted to use sequence module instead of decide module so that it will be more clear, less chance of making errors. We use 6 stations and 5 routes. We also use whole module to introduce the queue outside of the store. We also use bulking system to make it accurate animation and simulation module that sometimes people just don't want to wait in the line and they give up and they leave. So our model is also accurate with the bulking system. We ran our simulation for 3 hours, which is in peak hours, 8 p.m. to 11 p.m. We ran our simulation with 20 replications. We ran with 30, 40, and 50 replications as well, but the results were not different. So we thought the 20 replications would be good enough. Now my friend Nikita will be talking about our model.
Here you can see the model which we built using Arena. As you can see, once we try to make the model close to the real world system, it gets way more complicated than the flowchart. Here you can see the arrive module. Here's the customer arrives, and then here's the assign module. Customers go through this, and this sequence assign the this as this module assigns sequence using discrete distribution. Then you see a couple of decide modules which represent bulking system, and here's the record module which records number of bulk customers, and here the leave. And here's the hold module which represents the line outside of the store. Since we're using sequence logic, we need to put stations and routes. Then all the customers go through checkout, and then they finally leave. We put a hold module to introduce the QoS outside of the store. The logic behind this module is as following. If there are 20 or more people inside of the store, no more people can come in and they have to wait outside. As soon as the customer or customers walk out, more customers can walk in. The number of customers walk out should be equal to the number of customers walk in. We built an expression which you can see here, which represents number of customers inside of the store. We also created a bulking system. Some people, when they see that the line outside is too long, they give up and leave because they don't want to wait. To simulate this process, we put two decide modules and build an expression. As a result, if there are more than 5 people waiting outside, then a half of people leave. To do that, we put the first decide module and we build an expression. Then those people which decide to leave, they go through another decide module, which is a two-way by chance, and 50% of them leave, and 50% of them decide to stay and wait in the line. Here you can see some of our results of our data collection process. Multiple time studies were conducted to collect needed data. What we collected was the arriving time of customer during peak hours, times for checkout, choosing groceries, getting a drink, getting a pizza, and walking in the store. Since there is a huge impact of human factor, it is really hard to generalize the data and create the distribution, but we did it to the best of our ability to make our model as close as possible to the real world. On this slide, you can see screenshots of our animation. Here you can see the screenshot of our entities, our customers. As you can see, we customize them, and once the customers goes through the get pizza process, you can see how he's carrying a pizza. The same thing with the drink. Here you can see the resource in the busy status. Whenever it's busy, you can see how the the pizza server is giving a pizza to a customer. Here's a screenshot of the whole animation. And now take take a look how the animation runs. Let's open Arena. Here's our animation, and let's run it. Also, we have animation clock, which starts at 8 p.m. and finishes at 11 p.m. since it's a terminating simulation. Let's zoom in. You can see customers walk in, and then you see the pictures change. Let's make it a little bit faster. You can see that more and more customers walk in, and then around 9 o'clock, that's when the lines are the biggest. Alright. On this slide, you can see the results which we got using Process Analyzer. As you can see, we created 5 different scenarios, including the original one. We have one scenario where we added a fountain, one scenario where we added a cashier, the next one where we added a pizza server, and then the last one we actually added 2 resources, one cashier and one pizza server. We focus on the following responses: average total time in the system spent by an entity, and average and maximum time spent in the queues to get inside, to get pizza, and to go to the cashier. Number of both customers and number of total people served are our focus as well. In the end, we decided that the option add one cashier is the best for us. Even though that hiring pizza server and the cashier is better by a little bit, we're sure that the results which we got from hiring one cashier are good enough, and hiring 2 people would be too expensive, which would make the place less profitable. On this slide, you can see that the results which we got and we put into 2 tables: the original simulation and the updated simulation. Also, you can see the graph, which where the green line represents the time spent during running an original simulation, and here's the updated simulation.
So in conclusion, we believe that we were able to create an accurate simulation model which fit the real life situation. As my friend Nikita mentioned earlier, that as a result of our process analyzer, we concluded that adding another cashier for peak hours will be the best alternative. Thank you so much.